All right, hello everyone. Our first speaker of the day is going to be Willis from American Rivers. She's going to talk about the California Environmental Flow Framework and tell us a little bit about a case study on the Little Shasta River. We are re-recording the beginning of this talk because we did not hit record. So there'll be a jump after a few slides, but really appreciate Ann speaking for us today. Ann, take it away.
Thanks so much, Randy, and thanks everybody for checking out this talk. I really appreciated the opportunity to share our work. This is about a research project that I did when I was still working at the University of California, Davis, and it was something I did in collaboration with a number of other teammates, including UC Berkeley and the Nature Conservancy. And what I'd like to share with you today are, the differences between functional flows, which is a phrase some people may be familiar with, and the California Environmental Flows Framework. One is a concept and one is really a pathway to implementation. And so understanding the differences between those two will make it a lot easier to follow along with the work that we did. Then I want to talk a little bit about the details of how we applied the California Environmental Flows Framework in a specific watershed, the Little Shasta River, which is a tributary to the Shasta and then the Klamath. And then finally, we'll share the results that we came up with, which will show flow recommendations for ecological function in the Little Shasta framework, broken down by year type, dry, moderate, and wet years. And we'll talk a little bit about how we can apply this framework to different rivers throughout California in an effort to bring dynamic and protective environmental flows to each of these streams. So first, just a little bit more about the team that's come up with this concept. The California Environmental Flows Framework actually has a very extensive technical team that includes state agencies, nonprofits, other universities, and they've been really working on this effort for several years. This has been something that's been done, both supported by and funded by the State Water Resources Control Board. And the question that it fundamentally tries to answer is, one, how do you make variable flow recommendations in different watersheds throughout the state that are protective of ecological function, but also provide an opportunity for all the other water use that's demanded from a lot of these watersheds? To go into more detail, let's first talk about what does it even mean to be a functional flow. And here is where I'm going to hand it off to past Ann. Thank you so much.
The idea of functional flows is that flow isn't just about an amount of water, it's about its purpose. What is it achieving? How is it interacting with the channel, with the habitat to create unique geomorphic, ecologic, and biogeochemical processes that are the foundation of the ecosystems that we're also interested in preserving? And how does this vary in space and time? Is it sufficient to simply make some flow recommendations for one location in a river, or do we need to vary them as we go through the watershed? So that's a concept of functional flows. But here, let me do that. But how do we turn that into something that actually has a number that people can work with and manage? Well, we break down each of these components of the hydrograph that we identify as having really important ecosystem functions. And then we have these different metrics. The metrics identify amounts of water, magnitude, it's timing of water, when do we need it? It's the duration of water, if we're talking about peak flows or base flows, like, well, how long do they really need to persist? We're talking also about frequency. Do you need every single one that occurs in a water year, or after you get a few, do you have some flexibility to maybe not send the next peak flow or the next storm downstream? And we also have duration, how long we think it needs to last, and then rate of change. Rate of change is just about, how quickly do we need to, or gently do we need to draw down, say, a snowmelt pulse or a peak flow? A lot of that is more specific to reservoir operations, but I think if your diversion season happens to overlap, say, with a snowmelt recession, it can apply here as well. Oh, now the clicker's not working. It was just a moment ago, and now it stopped. I love going first. I love it so much. Oh, perfect. So if I just do the down arrow, that should work. Is that the one?
I think it went right.
Right, okay. Oh, good, perfect. So those are the concepts of functional flows, but how does that then translate to CEFF, the California Environmental Flows Framework? Well, CEFF is this process that we go through to then identify what each of these metrics are. And it also provides an explicit forum for engaging the community so that it's really, transparent from day one. That being said, when we started this project, we didn't even know if the science was going to work. So the purpose of the Little Shasta project was to take the first two sections of CEFF, and each section is just a part of the process. So section A is about saying, if I had unimpaired flows and I wanted to figure out what my functional flow components are, what would that be? And that's great, but there's essentially no river that has unimpaired flows, or frankly, no degradation, because ecological function, again, is the relationship of flow with habitat. So that brings us to section B, which is to say, well, that's nice. Now we know kind of what the goal is, but what are we actually working with? What is the condition of the watershed? Where is water going? Are there things that are not flow related that are causing problems? Because we can put all the water in the world into a river, but if it's deeply incised and has no access to floodplain and there's no riparian cover, there's no function that's going to be achieved from putting that water in stream. And we need to know where that's happening and what those problems are so we can flag it when we're making these recommendations. Those are the first two sections of CEFF. The final section is to say, well, once we know what our flows are for an ecosystem, what does this mean for the community? Is this workable? Because we have these water rights and litigation. And so I feel like the step from section B to section C is the pragmatic step, where we take this from being aspirational and we make it operational. And it can be, I think, challenging, but I think it's easier if you can make it transparent in your process and explicit. So that's what section C is. Now, one thing that's a little, I think, important about CEFF is you can choose to focus on a particular ecological objective. For example, perhaps you want to implement flow recommendations for key listed species. You can do that. But the fundamental premise of CEFF is that the ecosystem needs to function as a whole. Now, I am an engineer. I started off at the Army Corps. The whole basis of my education was that we could take these pieces and discretize it into the flows like riparian things need and frogs need and fish need, and you could do pieces at a time and it would work. And after 15 years of doing it like this, I haven't actually seen an example of that happening. So I will just be transparent that my personal skepticism is that you really can't pull these pieces of an ecosystem apart and just do one. But sometimes that's what you have to do. And so there is a way to do it through this process. So I think just the key takeaways for this things are functional flows are designed to be holistic. They're looking at the whole river, and they're not just looking at the whole ecosystem, but they're also looking at the intersection of flow and habitat. And that CEFF is the framework that guides you through being able to take those principles and make it into an operational plan. So real quickly for the Little Shasta River, this is the, here's the watershed. And the first thing our team did is say, well, Little Shasta is really different from its headwaters down to its mouth. Here's just some photos I took of the different kinds of habitat. You can see, especially in the upstream reaches, there's some really lovely habitat that currently exists. And my colleague, Rob Lusardi, who's done snorkel surveys up here, there are lamprey that live here right now. There are trout that live here right now. There is functioning cold water habitat in this watershed right now. Problem is nothing can actually get to it if it needs to migrate. It's the lower reaches that really, I would say, are the most impaired in terms of ecosystem function, not least of which is because they routinely go dry in the summers. We wanted to do it for all three locations, but one of the limitations of our project was we wanted to use available data. We weren't doing any new modeling ourselves. And it turns out with some of the available data in the National Hydrography data set, it recognized the Montague Water Conservation District Canal, which is that line just below LOI 3, as a tributary to the Little Shasta River. We could not understand why in our first just gut check run, we were getting flows of 100 CFS recommended in the Little Shasta River every summer. And then we realized the Montague Canal's capacity was taking 100 CFS past the river every summer. And computers think what computers think. It thought it was a tributary. So we said, okay, well, we're not going to build a whole model for the downstream portions of the river. So let's just test this in the upstream portion where we could validate through some existing data that the numbers we were getting were reflective of real patterns of stream flow. So we took out the lower parts from our initial project. And then through this process, we were able to ask some really key questions. Again, you know, we're a few years down the line of having a program like the California Environmental Flows Framework. The idea of functional flows has been around for about 8 years now, but at the time it was brand new. And so we decided not to just focus on any single species. We said, what if we did this? And our objective was to restore the full ecological function with the flow recommendations we made. And how do we take into account some of the key aspects of the Little Shasta River, which include the fact that there are discrete off-channel groundwater fed springs that play really important roles in terms of defining that stream's chemistry, additional quantity of water to the river. It affects temperature patterns, but in ways that aren't naturally captured when you're only looking at surface flow runoff. So we wanted to make sure that we were really mindful of that. And then the other thing we were just curious about was the state of the river itself. Like, does it have floodplain access? Is it incised? There's a lot of branching that goes on along here. And so we were able to use some existing LiDAR data to look at that. And again, it was all about the nexus of where flow and habitat come together to then produce a function. The table I'm about to show you, just like, stay with me. So this is the outcome of this, and I want to explain why I'm presenting this as a table and not a hydrograph. There's a couple of different reasons. One, I wanted to show that it was really important for us to recognize that flows don't just need to be managed in dry years. They need to be managed in all years. We know that California ecosystems evolve to adapt to extremes. Dry years are manageable if you have wet years. But if every wet year is turned into an artificial dry year, then you're really stressing your ecosystem far beyond what it can actually recover from. So we wanted to build a flow schedule for all years. And we broke it down to dry years, moderate years, and wet years. But the other thing that's really important about this table is not just the numbers that are outside the parentheses, which are like the median flows or the median day, or and in terms of day, we were talking about a water year day. So one starts at October 1st. But it's also what's in the parentheses, because what's important is not just a flow, but flow variability. And then we wanted to see if this was a program that could introduce the ability to have variability in a managed system. And so one of the ways that we've used this, not in the Little Shasta River, but we did a very similar project where we came up with water year type flows for every tributary in the San Joaquin. And we tied those flows to a gauge. And we said, if that gauge, the natural stream flow is this, does it fit within the range of flows that are acceptable for that particular metric? If it's a 2-year peak flow, not every peak flow is 143 CFS. Sometimes it's lower, sometimes it's higher. It just depends on the year type, and bringing that variability back into the system in a managed way was important. So every number has some wiggle room, and that gives us flexibility to then tie management to actual hydrologic conditions. And to me, that is the key of this program. Okay. So the next steps were really, if you want to make this operational, you need a gauge, you need monitoring, you need something that's actually telling you what's in the river so you know what you have to work with. And that was one of the first things we had to do in the Little Shasta, is make a gauge re-operational. And the Nature Conservancy came up with the funding for that. And it's a publicly accessible gauge that we use. The other thing that was really important about this is we only took this testing process, this test drive, through looking at what flows are needed to support the ecosystem, but with no consideration of what's happening in the community at all. So the community did not give any input into what ecological objectives we pick, because we said we want to pick them all. We need to see if this program works across the board. So the difference between what we did and what would happen in an actual process where CEFF is being applied is you would have to engage the community and try and understand what are really the priorities, because there have to be priorities. I think when you're just starting something new, telling a community you want it all right away is the fastest way to get every door shut and make no progress. But if we can prioritize and be really specific about why and where and what, and then when those needs end, there's been more flexibility and willingness of those landowners to work with us. I think we may have taken up the question time with technical issues, but I'm happy to happy to defer to you. Yes, Dave.
I don't know if you can answer this, but I'm curious why you couldn't simply delete the ditch portion of the hot tub, which you did years ago when it first came out. Every ditch was half the value of a hot tub.
Yeah, no, we tried that because we thought it would be that simple too. And then when we took some of the data we were getting and comparing it to the upstream patterns of flow, it didn't make sense. The numbers weren't translating well. And so it's not clear to me exactly how the water that was being routed through the USGS models were being sourced. And we actually, I mean, I would say we didn't have the scope to do it, but we were scientists. We were like, well, let's just try. And so we tried many different ways of reshaping the watershed to see if we could replicate those flows, and we never could. So I think you're spot on for exactly what the first step was to try, and it just, we could never validate it with the data we had. Yes.
Fisheries data for Little Shasta? Has Lasardi summarized the fisheries data for Little Shasta?
So we do have, okay, I'll show you the slide just so that you're all aware of what it is, but it is missing the detail that you're looking for. So this slide has all of these papers, and all of these papers are full access. You don't need like special permission or to pay to get any of them. This is all the different pieces of what we worked on. But what you're asking for the fish data, we actually have that in publicly accessible reports that are on the UC Davis website. And I can't think of exactly the pathway off the top of my head, but if you catch up with me, I'll make sure to share it, and maybe I'll send it to Randy too in case that's something we can add.
Yep.
Mm-hmm.
Yes.
When you say you're going to engage the community, what does that mean? What is community?
Well, it's been a number of different folks. I actually sent you the report when I was done, Mike. I also started to send it to individual landowners who had given us access to their properties to monitor. That was a really interesting process. It typically looked like me sending them a report, being ghosted for about a month, and then getting a call saying, okay, I'm ready to talk to you now. I mean, this didn't land very well for them. But the point that I've been making to the community, and hopefully, you know, I'm not speaking it out of turn, is that I said, we see what's coming with curtailments, with drought. The status quo is not defensible. Just seeing if they could wait it out is not a good strategy. And I feel that we've had enough encouragement from the agencies that landowners that have been proactive and really willing to do material work that gives something back and brings in some balance, there's been space to do that work. And the ones who haven't and have waited, they're just left with worse choices that people end up making for them in the end. So this is the conversation I'm having with the community, and just really trying to encourage them to come forward proactively to engage. And then the other point I make to them is that I don't believe, it hasn't been my experience in the Little Shasta or any place else I've worked, that there's really any single landowner that can do it all, but everybody does have a part. And so really recognizing what each landowner's specific part is and having them contribute it, knowing that really what we might not see as a benefit until we have a critical mass engaged. That's something that I'm trying to be really transparent with them about too. Yes, Michael.
I've got a friend who's got a large ranch on the Little Shasta,
Uh-huh.
and he's always told me that there's several illegal diversions further up in the watershed. Did you ever run in and encounter that?
Michael, come on. I will say this. The landowners who typically are proactive about working with a public university, and we've been transparent, if you're a public university and it's public dollars, it's public data, that's not negotiable. And we publish, and that's public data, that's not negotiable. Those landowners don't tend to be people who have something to hide. However, when you look at a gauge or even two gauges, it can be very clear that the numbers don't add up. How to explain that? I can make a really educated guess, but I've never seen it personally. So, yeah, that's my answer. Yeah.
Any other questions? All right, thank you, Ann.
Thank you.